So before handing over to Paul Graister, I just wanted to take the opportunity, since we have all 5 prize winners in one room, and that's the first time I get to say congratulations on behalf of the panel and the campaign team. We were so impressed with what you have proposed, and I wish you all the best for the implementation and looking forward to sharing it with you. So congratulations, Cardiff University. Congratulations to Nottingham University, King's College London, Imperial College, and the Open University. So really well done, everyone.
Thank you very much, Jens. So first of all, can I echo everything that Ulrika and Jens said at the beginning about how important it is that this piece of work is being done. But more importantly, can I thank all of you who've come along today and who engaging in this event, but also your wider teams who probably will have engaged with this activity beforehand, maybe when you were thinking about putting in a bid. But also thank you to the 34 applications that I thoroughly enjoyed reading, the amount that you put in. And then finally, obviously, to the 5 grant awardees. It's been really good to see what are 5 very diverse, but hopefully instrumental activities that will happen over the next few years. And I've been in higher education for 48 years. And I've never seen anything like this previously, an opportunity for us to come together as a community and think about the future of our discipline in relation to the teaching and learning of undergraduate students and to their futures and beyond. So that is absolutely amazing. And before I pass over to Rob, I'm going to say something about the 3 presentations that we had earlier. So I very much support what ACME are doing and what Courtney and Paul have been doing. One thing that is interesting that I think Dan was alluding to is that, yes, we had a 10.5% increase in reported by UCAS in the numbers entrance to mathematical sciences this September. What I'd like to understand is who those students are. What are those degrees in mathematical sciences? Because I don't believe they're all mathematics degrees. And secondly, where have all those students now gone? Are we seeing this strong concentration in the higher tariff universities? So this is work still to be done, I think. Anyway, without no further ado, can I introduce you to Rob Wilson from Cardiff University, who is going to talk to us about the plans and maybe the challenges with the programme that they're introducing. So thank you, Rob.
Well, diolch yn fawr. Prynawn da pawb. I can see the worry, I'm not going to speak at all. I just want to say thank you very much and good afternoon to everyone. Hopefully you can sense through this talk my excitement for this opportunity. I'm really grateful to be here today, and I'm especially looking forward to seeing what the other successful bids have as part of the proposals as well. And just as part of my introduction, I wanted to say a massive thank you, obviously, to the campaign for mathematical sciences for kick-starting and supporting this work to happen. What I've got planned is to, as Paul said, share with you some of the ideas that we've got, maybe some of the challenges associated with that as well, some of which we've already heard about already. So, a little bit of context as far as our programme is concerned, Mathematics for the Modern World. We took initial inspiration from the Future Generations Act of Wales. Wales still, I believe, is the only country that kind of mandates, if you like, this idea that we leave the country in a better place than which we currently find it. And its aim is to do that through forward thinking, diversifying engagement, and collaboration. So certainly we felt it was those things that fed into the kind of pillars that we built around this particular degree programme. And what I'm planning on doing is going through some of these in a bit more detail to highlight specifically what it is that we've got, but also to talk about how we can develop our graduates and think about how they can respond with confidence to global challenges and act as flag bearers of the discipline going forward. Okay. So like I said, what specifically is it that we are looking at through this new degree programme, which we are planning on starting from September 2026. So, first of all, a lot has been made so far about kind of diversification. And the recent report from the Observatory of Mathematical Sciences, amongst others, highlighted the need to attract more students from a wider cross-section of backgrounds. So one thing we were particularly noticed was something else from the report that Paul highlighted earlier, and how Wales has as a region, has a low number of first degree mathematics students going on to study mathematics at university. So how could we perhaps attract a slightly different and more diverse group of students into the subject? So we're going to introduce a foundation here to support that to happen, to broaden our background, to potentially attract those students who hadn't perhaps previously thought about continuing into mathematics. There are some particular issues in Wales with regards to access to things like further maths, for example. We've highlighted already some of the specific socio-economic backgrounds in many parts of Wales that might be a potential blocker here. And, something that is of particular kind of personal passion to myself, in that I never applied to study mathematics at university. And yet here I am a number of years later. Okay, so that is one area that we felt where we could make a difference through this new programme. The content as well. Yes, I think it is important that we maintain this essential core of mathematics. You know, there's no getting away from the importance of analysis, linear algebra, calculus, and so on. Okay, that thread needs to be there. Try to highlight that this is not a degree light, a mathematics degree light. Okay, it has to have those fundamentals. But what we are planning is to make some of the skills associated and the attributes associated with modern mathematics be right more at the forefront and visible through what is done and embedded throughout, not as a matter of consequence of. So how are we going to do that? We've got modules from the start of the programme highlighting the importance of communication, highlighting the development of creativity through the subject, and immediately starting to look beyond. Where is maths going? What are those ideas? When you turn on Netflix and it tells you what you're going to watch next, where does that come from? And embedding that through the programme. Then in year one, further foundation building. Then looking, as well as that, looking at some more forward-thinking ideas, modern mathematical practices. For example, thinking about how computational support for proof is included in the discipline, thinking about open sourcing, thinking about ethical use of data, all those things which are very much needed as part of a programme if we're talking about the future of the subject. We are going to include variants that allow students an option to have an experiential year, so out in placement so they can apply what they're doing, studying abroad so that they can witness different cultures from across the globe. And then in the final year, we've got a capstone module where students will be applying these things that they've been learning in their practice on the kind of global challenges that we all currently face. Alongside that, we have a suite of contemporary modules, including where the introduction to the learning and teaching of mathematics, other modules on big data, machine learning, AI, and things of that type. The other particular strand that we were keen to explore was a targeted outreach activity. So we do some outreach already. We wanted to build upon that to develop more targeted and sustained program of engagement with schools, so that we can, utilize probably our greatest resource, which is our students themselves, to inspire the next generation of mathematicians. I'm pleased to say we've already done some work in this area, and we've identified 7 priority schools in some of the most deprived areas of the country, where we are looking to roll out some of this activity over the coming years. I'm not going to highlight all of these things because some of these I think we've already touched upon today, most notably about kind of teacher recruitment and pipeline issues there. I think it is a challenge to keep momentum, particularly with technological change. If you think about not just what we teach, but how we teach it, a really good example of that, we haven't mentioned it much today, is the use of AI. There's some really interesting work happening there at the moment around a kind of a two-lane method of assessment, for example, thinking about the kind of closed book exam, those kind of robust mechanisms versus the open as well, and how we blend those things. So I think the program that we're looking at is looking to see how we can suitably blend such things going forward. There are potential risks to the theoretical areas. I've already highlighted how everything needs to be underpinned by sound mathematical ideas. But how do we ensure that that thread remains part of what is deemed a standard mathematics program, but is still looking towards the future? Those are just some of the risks, but kind of despite or in spite of all of that, I would say that what we've tried to develop is in response to some of the challenges that we are currently facing. And hopefully, if nothing else, you've got some sense of our excitement to do this, because we are very much looking forward to having the opportunity to drive this forward along with the other institutions as well, and work with the as yet undiscovered problem solvers and game changers of the future generations. Diolch yn fawr.
Thank you very much, Rob, particularly for making my life a little easier. You've well kept in the time, given I gave you slightly under the 40 minutes. Initial questions? Anyone obvious? Yes, the lady in green.
Hi, thanks for a nice presentation. I just wanted to ask about your outreach. Will that be credit bearing, or will students be paid, or a combination of both?
So it's a bit of both. What we were actually planning is for, certainly to start with, is that it is part of the credit-bearing modules as well, so it is embedded into the programme. If we're going to talk about or highlight the need for important communicators, then what better opportunity to get students to do some of that. So it will be a blend, but it will include that embedded nature as well.
I'll take one more, yes?
On that same subject, what age groups are the schools?
So the schools are currently secondary levels. That's what we're working with. Like I said, we work with the institution to look at the kind of the socioeconomic background of those schools in particular. So that's where we'll be concentrating at least to start.
11 to 15? Or?
Yes, sorry. So yeah, it'll be at that secondary level and looking at that part of the pipeline predominantly. If it expands, then it'd be great. But yeah, that's the plan.
Thank you very much again, Rob. Chris, so a huge delight to me, of course, when I arrived, that I realised that the 5 institutions that were the award grant winners, actually had their representatives here. So, because although I'd read the bids, there's no way I was going to be able to deliver any of them, particularly if some of them were going to be partly in Welsh. So it's now my delight to introduce Chris Hallsworth from Imperial College, who's going to again talk to us about the programme of work at Imperial. And can I just say that I guess quite a lot of you are really interested to know what these are going to look like, and you're not going to hear a lot within 10 minutes. So please make a note of all your questions and make a nuisance of yourselves asking them further questions over the course of the next 2 days. Anyway, thank you very much, Chris.
That's great, thanks.
Yes.
Hi everyone, I'm Chris Hallsworth. I'm the Director of Undergraduate Studies in the Maths Department at Imperial. I'll start off by saying thank you very much to the LMS for the support. We're really grateful and also really excited to see what the other bids are going to say. So I'm going to talk about future maths degrees at Imperial. I'll start off with some vision. So increasingly what's true of our graduates is that they need to be able to turn ideas into code. So we're used to students learning to be much more proficient at thinking abstractly, but the important skill going forward is moving along the axis from abstraction to concrete instantiation, and that's something that we think is increasingly the case. Increasingly, our graduates need to work productively across the discipline, so in productive cross-disciplinary teams. The students need to be able to communicate clearly and persuasively with data when they go into the workforce or when they become research mathematicians. And our vision is to redevelop our degree programs with those skills in mind. And we'll do that by leveraging the local expertise at Imperial, emerging but also established. So the first point is around foundational pure mathematics, so using interactive theorem provers, and at Imperial that usually means lean, to teach rigorous mathematics better. In the more applied side, and particularly in statistics, we want to bring students together to work collaboratively and to be assessed collaboratively. We want to bring them into closer contact with data from primary research. Something that's true of mathematics is that students don't tend to engage with primary research until quite late in the degree, if at all. Whereas the other subjects in the same faculty as us, life sciences, chemistry and physics, it's much more common to be engaging with primary research quite a lot earlier. So that's something that we think can change, particularly through applied statistics work. And then thirdly, something that's come up again and again already today, this national challenge about the shortage of mathematics teachers. We want to integrate outreach into the curriculum, and part of that is encouraging our graduates to consider teaching as a destination. But it's also a vehicle for improving transferable skills, communication skills in particular. So I'll say a bit more about the 3 strands of our plan. So firstly, interactive theorem provers. So year 1 mathematics at Imperial starts with our introduction to university mathematics and then moves on to rigorous pure maths, applied maths and statistics. We intend to teach particularly pure maths, but also some of our probability statistics and applied maths, integrated with lean, integrated with formal theorem proving. We don't think that that's just because interactive theorem proving is nice and trendy, even though that certainly is the case, and lots of my colleagues do think that. We think that really there's transformative potential in the use of automated theorem provers to teach pure mathematics and the writing of mathematics much better. One reason for that is that students get instantaneous feedback on their arguments. It's much harder to make mistakes in writing pure mathematics when the computer won't let you, when the computer simply says no. And that's really, I think, a very positive thing about working with Lean and its friends. And it also offers students a new perspective on the structure of a proof. So quite a lot of students come through pure mathematics not really understanding the idea of proof, how to write a proof. We've had some success in making it more accessible through almost a gamification, certainly of analysis proofs, but not many students get past that, get a real kind of threshold understanding of what it is to write a proof. And we think that using Lean really helps. It really helps students to package and unpackage a mathematical argument. Secondly, data-rich statistics. So I'm a statistician, so this is very much my interest, and something I've worked on already with Joanna, who's also in the audience. We want to develop resources, so data-rich resources, so curated data sets and case studies using interesting data sets across varied problem domains, so that students are seeing how mathematics and data science and statistics are used across science, engineering, finance. We want students to engage with published research or available case studies, publicly available data, replicating analyses and extending those analyses and communicating that. Particularly this strand is quite a natural setting for collaborative work, collaborative assessment as well in the first 2 years of our program. And it's really part of the curriculum where students can co-create. So something we heard earlier is that, in a sense, students and their parents aren't always sophisticated consumers of the product at the point that they apply or they come in. They might not know very much about what mathematics and statistics involve, but in this area of the curriculum, in the choice of problems to work on, in the choice of data to collect, students can really get a lot more agency. So it's a natural area for co-creation. And the third strand is mathematics education. We'd like to develop final year electives in communicating mathematics and communicating with data. The vision for this is that students will essentially be part of a structured program of outreach, and that's working with the Imperial College London Mathematics School. So partly it's supporting that relationship. It's a way that students can learn to develop teaching resources, teaching interventions. Thinking about this huge national problem of the shortage of maths teachers, we'd also like to offer the modules that we're intending to develop in communicating maths, communication with data, as a micro-credential, so a postgraduate certificate, aimed at maths teachers working in schools who don't currently have the level of mathematics that they would like. We think this fits very naturally with the lifelong learning entitlement, which the government has proposed. With the LMS grant, we're recruiting teaching fellows for 2-year posts to work on each strand, and we're also going to recruit student partners shared between the strands to co-create the new curriculum. What we're doing, we think, has benefits far beyond the walls of Imperial. Through outreach, we want to widen participation. So we want to encourage students to consider teaching as a career. And as others have suggested, there are different ways that you can do that. Partly, this is something that we should encourage students to be involved in through paying them to be part of research projects, internships. But also, we think that there's, modules bear credit, and communication skills are developed in these modules. So being part of a structured outreach program is something that we can award degree credit for. Longer term, we'd like our outreach, which is currently centred on the Imperial College Math School, to be structured into a roadshow, a national roadshow, and we'd also like to improve our online presence. It's important for us to release resources to the community. We really want to lower barriers to adoption of resources we offer by making resources modular in the choice of topic and the ordering. So part of this is the resources we're developing to support the use of lean and formal methods in the teaching of proof. So not everybody will want to use the same topics. Not everybody will have as much time to devote to this. So we want to create adaptable resources. We're trying to, one of our first aims is to develop a framework for sharing of resources for formalization and also our data case studies. We've done quite a lot already with education researchers, so some early work introducing formal methods by Kevin Buzzard has been studied quite intensively by education researchers, so we have some early understanding of what works. There's more to do. And to disseminate what we're going to do, we're organising conference sessions next year and in 2027 to disseminate resources and findings. And we're planning as well to offer professional development sessions to share best practice. That's what we intend to do over the next few years. I do have a timeline. So at the moment, we're in the process of recruiting and writing specifications for our new modules. Next year, we'll be piloting particularly the work with formalization with our joint maths and computing cohort, and also working with student partners to develop new resources. Then in 2027, we'll be launching our new joint maths and computing degree. So in a sense, we have an existing joint maths and computing program, but we're expanding it quite substantially. It's currently about 50 students. The vision is for it to be much larger, but we're taking an intermediate step in 2027 for it to go to about 140 students. And around the same time, we also hope to launch our PG Cert in education. And then 2028, we hope to launch the revamped maths program as well. That's our timeline. I think I'll stop there. I'm happy to take questions.
Initial questions? Yeah.
How much time do you think you'll have to dedicate to specifically teaching lean to new first year students?
The vision longer term is for it to be embedded entirely in how we teach first year. So what we're going to do in the pilot is work with our joint maths and computing students who are quite amenable to the idea of working with formal methods anyway. So the aim is for the methods to be based in lean. So it will be there'll be an initial upskilling where students need to become comfortable. So in the first couple of weeks, what is currently our introduction to university maths, there's going to be a lot of lean in that. It won't necessarily be full time. But no, the idea is also that you get some quite substantial efficiencies by doing it that way. So it's not as if it's taking away from something else, rather it's making other things more efficient. Does that make sense? Not numbers, but...
Another question? Up to one more question. Doesn't that limit you? Well, I'm sure some of you... Go on, thank
But
you.
if you have the Imperial Math School, don't you preach to the converted there a little bit?
Not well, as it happens, no. So we think we've had our first cohort do university applications. What seems to be the case for our first cohort in the math school is that they're mostly applied to do things which are not maths. So in that sense, it's not quite for reaching to the converted, but certainly that population is enriched for people who might be likely to come and do mathematics. That's okay, I think. But no, I don't really think there are many at all who've applied to do maths in the maths school.
So challenging questions also welcome. Anyway, thanks very much.
Thank you.
Thank you very much. Okay, so our next contributor is Dan Abramson from King's College London, who is going to take us through their plans and maybe some of their challenges too. But they're going to work with your former institution as head of King's College Maths School. Well, we'll wait and see. Thank you, Dan.
Thank you, Paul. Hello, I'm Danny Abramson, as Paul said, and as you can see, I'm very much on brand, red and red, and Paul did mention my link to King's College London Maths School, which I was where I was the founding teacher, and you may have seen the nod to that in my other choice of colour. Thank you very much for the opportunity to speak. I've seen a lot of parallels between our thinking and that at Cardiff and to some extent in the Imperial already, so it's great to have this community opportunity. Let's swap button press. They've got no arrows. Let's try that one. There is no arrow. We at King's College London are going to launch a new degree programme, quantitative mathematics, and it comes with four thoughts. So one was, when we went into this, looking at maths degrees as they stand, especially universities with higher entry requirements, I think they are built by mathematicians for future mathematicians principally. We wanted to build something that was more specifically targeted at young people who want to be mathematicians in quote-unquote the real world, in industry, in government, in business, in entrepreneurship, in charities, young people who want to see change and impact, and quite possibly cash too. Noting the market and the data we've seen talked about already today, where at school level, there are lots of students choosing academic routes in mathematics. We've all seen over 100,000 in Maths A-level, and by far the most popular A-level, and further maths numbers are increasing too. But there's noting that there's lots of those and not as many people, or a low proportion of those going into mathematical study, we have targeted this at students who have got a good A-level in mathematics, but have not studied A-level further mathematics. And I think there's a lot of students in there, in my experience, who may still want to study mathematics, but may not be getting the right messaging. And I think a lot of this, and this whole today and tomorrow discussions, is about optics and marketing of mathematics, and broadening our perspective and how we talk about it to young people. So there's lots of students who will have had no opportunity to study further mathematics, or no easy opportunity to take that choice. There's lots of students, especially girls, who have more diverse academic interests and are being forced to choose 3 things, age 16, and the idea of taking 2/3 of that study in maths is somewhat galling, even if they love it. And there's lots of students who are kind of late bloomers in their interest in mathematics, who discover they might want to take it further at a later stage than 15, 16, when they've had to choose those A-level topics. So, what have we cooked up? Well, we have a vision underpinning this with 2 phrases: enrich the magic, inject the science. So what on earth am I talking about? Well, whilst we are talking about, we are talking about an applied form of mathematics in the main, we are not wanting to remove the magic of mathematics, right? At the heart of mathematics is a mode of thought that is unique and powerful, and our degree programme will place mathematical thinking at the core, and our goal is to educate confident and capable mathematical thinkers in that way. I also think there is a science of mathematics that we're trying to bring in that is more visible, will be more visible in this version of our degree than the traditional degree programme in mathematics at King's. Mathematics in industry, in the workplace, engage in a process that we have called quantitative modelling. It encompasses, well, our definition of this would encompass both traditional mathematical models and statistical modelling. And I think this is a science as much as it is part of the mathematical discipline. It's a learned process that can be applied consistently to real-world problems and lead to tangible insights and improvements. And our students, we want to master that science by practicing it, by doing lots of quantitative modelling in curated contexts where they will do projects involving real-world problems and develop the hard and so-called soft skills that are often harder to develop that are required. So you need to be good at modelling and mathematical thinking, but you also need professional skills, project management, written and verbal communication, working within and with a team. They're hard to master, and certainly in my experience so far, and I've only been working at King's College London Professor of Practice for a couple of years, are not well mastered by the majority of our undergraduates because our existing degree program doesn't really target that and work on it hard. It sort of comes in around the side sometimes if you're lucky. So what about the curriculum? Well, I thought I'd show you the gory detail here. So we have got a new degree program, and broadly that entails a very new, well, a mostly new first year, all the stuff at the top part of the page, and mainly in the second and third years they're accessing existing modules that the department offers. And it comes in streams, so the pink stuff is, roughly speaking, pure mathematics, and in the first year there's an epic amount of what we're calling foundational mathematics, 2 30-credit modules, mathematical foundations, mathematical methods and proofs, and I'll come to the teaching of those in a moment. And there's a very new thread of quantitative modelling, here QM, which has 4 modules with the labels QM on them, which progress through this experience of quantitative modelling. One foundational module that takes them end-to-end through the process and gives them the introductory experiences. Later on in the second year, focusing on more complicated systems and optimization problems, and then, well, that's not data-driven, it's supposed to be data-driven in the third year, and then a capstone project, much like there is at Cardiff, where they work with employers on problems that the employers set. And in there, also some knowledge stuff, computational methods, form mathematics, and numerical methods, a more advanced version of that, one actually that exists already. They'll do a bunch of probability and statistics. The compulsory modules are 2 core modules to probability and statistics. They're actually, if you know King's, they're currently called probability and statistics 1 and probability and statistics 2. They're going through a rebrand. And one called statistical modelling, which is kind of traditional linear models that you'd use in many statistical modelling problems. And then they will choose from a somewhat curated range of modules in the main threads of the mathematics curriculum. And underpinning this is the idea that we need to tackle fewer ideas in more depth if we have to bring in more stuff around the quantitative modelling, more experiential mathematics. Something that Tim Oates said a lot between 2010 and 2013, as you know him, fewer ideas and greater depth. So in that first year, when they're looking at mathematical foundations, we have a difficult challenge. We are both having to bring in the content they won't necessarily have studied, well, they won't have studied in further mathematics, A-level, that is considered to be prior knowledge to our main degree, and also cover the main elements of that first year study of our degree program that we think are essential to both access modules in year 2 and year 3. But our premise is the thinking is more important than the knowledge in that area. If they can come out being able to form mathematical arguments, knowing every result and every detail and every proof is actually less essential. How are we going to teach this stuff? Well, in foundational mathematics, we will take inspiration from my former employer, King's Math School, and use a very dialogic and collaborative approach in what is something more akin to a classroom than a traditional lecture and tutorials model. I will involve a little more contact hours and a blend between the lecture and tutorial and what you might call seminars. And in quantitative modelling, there'll also be fewer lectures and a lot more project work, a lot more lab time. And as for how we assess it, we just introduce, a lot of it is traditional. There'll be written examinations, almost all the modules, but in foundational mathematics, we're bringing in a kind of Voc element, mathematical presentations. And in the quantitative modelling, lots of stuff through coursework, through doing their projects, writing them up, presenting them to both technical and non-technical audiences, and introducing the idea of reflective logs where they can build up a sense of who they are, what their skills are, how good they are, and explaining ideas and also who they are, so that when they get to the end of the degree and they're going for interviews, they can present themselves really well. What's in the name? I was undecided about whether to tackle this at the beginning or the end. If you saw the news stories about which universities got awarded the funding by LMS, King's was in there with a degree title of Mathematics for Quantitative Problem Solving. And we are, at the moment, working through all the complexities of internal process. And I hats off to Cardiff, who are launching the degree programme in September 26. I did everything I could to try and get ours to launch in September 2027, and that was considered extremely fast for my institution. One of the feedbacks that we got through that process is that mathematics for quantitative problem solving is a bit of a mouthful, and we want to try and come up with something different. So our current proposal is quantitative mathematics. Now, it hasn't completed the internal process, so if the funders are very unkeen, I'm here to be talked to. But we have a definition, right? Quantitative mathematics combines rigorous mathematical thinking with modelling, computation, and data analysis to solve complex real-world problems. I think it's short, it's punchy, it's memorable, it aligns with the technical careers that is the goal of our education for these students. They are probably going into data science, mathematical modelling, quantitative analysis, financial engineering, risk management, and all of those areas will use this sort of an applied tool set. I think it, for me, is a union between the intellectual depth of what you might think of as traditional mathematics and a modern data-driven modern discipline, which is also mathematics, but it introduces a new terminology. And I think branding is really important, as I said earlier on this talk, and we want to put something new into the market. This is very much an experiment, a pilot, an idea. The actual numbers of students who can enroll into this program are relatively small. We more want to test out whether it works with students, whether they get benefit from it, whether the idea of something with a different name attracts mathematics to a broader audience. A couple of thank yous before I hand over to colleagues. One is to a member of the audience, Conrad Wolfram, who I think knows that a lot of the ideas that we've come into around the quantitative modelling thread have been inspired by Wolfram research and the work that they've done in what they call computer-based mathematics. The Royal Society also bringing in those ideas, and Robert Wilson, who you just heard from, who is our external specialist advisor. So it's wonderful to be part of this community where we can get such support. That's it from me.
Well, anyone that can understand the inner workings of senior managers and those decision makers in universities who don't have to market it and don't have to justify what they're doing and then deliver it, is a better person than me. So I wish you all good luck with your getting your programmes. Initial questions? Gentleman here.
Hello, thank you for an interesting talk. You mentioned at the end that you're expecting relatively low numbers of students enrolled on this program. Could you provide some more detail about that?
Yeah, absolutely.
Longer term plans as to where that might end up later in the process?
Yes, so first 3 years, as I said, very modest numbers, 30, 45, 55. Beyond that, we're expecting to jump up to 100 if the early signs are successful, but precise numbers beyond that we haven't set.
Thank you very much.
Thank you. Gentleman there.
You spoke about your capstone projects, actually this is also Cardiff as well, being essentially industrial projects where the problem is set by the business and it's all very much in collaboration with the business. That's great. Do you have enough businesses? Do you have enough problems suitable for a capstone project? This is where we have struggled.
Well, I'd love to talk about the challenges. I mean, right now I have a total of 0, so no. But we have started to talk to a lot of different businesses. Over the last few months, it's mainly been people in my team who know people, and just getting people interested in the idea. And then we have within the team structure and the funding, we have someone who's dedicated to bringing together formal employment partners. And then there's something in it for them, in that there's a piece of outreach for them, and possibly some good graduates that they might want to recruit, right? But at the moment, it remains to be seen. But it's so far into the future that our immediate challenge has been get the program approved, and then from January we're really working on into the detail. I think in my early conversations with people in employment, I can't see this being a massive problem, but I'd love to hear about the challenge you faced. As I said, we've taken inspiration from not only Wolfram, who have a number of such existing relationships and ideas for projects, but also the Math Schools Network, and they run a version of this that's much lighter in the mathematical content for 16 to 18-year-olds, and all of them work in groups of 4 on problems that are set by industry partners with cohorts of 60 to 100 per school across the country, and they're filling those projects every year. So I think it can be done.
I'll let you ask your questions after Chris, if that's all right. Anyway, thanks very much again, Dan. So our next speaker is Cathy Smith from the Open University, which is a very different kind of university compared with all the others for the reasons that Cathy will go into, and hopefully you'll enjoy what they propose doing.
First of all, I was going to say, I'm going to say a bit about the Open University, and then I'm going to say a bit about what we're doing. I was going to start with pictures of the 15 colleagues who were already working on this with me, and then the Isaac Newton Institute said I had to get written permission for every single image I used, and I was like, well, that's not happening over the weekend. So they're off, but I'm still saying it's not me. There's a lot of people working with us at the Open University. And we are the Open University, so even though they're working with us now, it's going to be slow. There we go. So a little bit about the OU. We dominate the part-time market in maths and stats. We have got a lot of full-time students, but as you can see there, we're kind of 3/4 of the part-time market. And most 2/3 of our students are in employment. Some of them are in full-time employment while they're studying with us. They can take a long time to get a degree, or they can take 3 years. They're quite evenly spread across, I put that in a funny place, but the socioeconomic quintiles, and 26% of them come with no A-levels. Being the Open University means that it is open access. You can sign on to our courses with no prerequisite mathematics, and you work your way up to a mathematics degree. Within that, we've got 25% of our female students are actually under 25, so they're not all old. Our modal age is somewhere between 25 and 34, but we've got quite a big cohort of young female students. We've also got young male students as well. And one of the things that's been happening since 2012 at the Open University is that the STEM faculty, the science faculty, have been really working on experiential and interactive learning at a distance. So if you think about the Open University, our students are all around the country. How do they do a practical? How do they do a lab? They no longer come on summer schools. That's something from the 1960s. What they do is they have they can log onto their computers, they can work together, they can access telescopes, they can access labs, they can access engineering practicals. And we saw this as a wonderful opportunity to bring maths, to make maths learning at the Open University be as interactive and as engaging as some of the science learning is. My background's in education, so part of the work that I've been doing is why do girls who are 18, working class students who are studying further maths, why do they choose not to go on and do maths degrees? Why do they drop maths degrees? Why do they drop further maths? And one of the things that we're thinking about is messaging. So it's not about we can turn you into a mathematician. It's about there is already space in maths for you to work in the ways that you prefer working. You don't have to change. Maths has diversity, and you can be the person you want to be and still do mathematics. We think that's a very important message. So we're looking at ways to build diversity into the programme. It's very exciting when you're an Open University student and you get lots and lots of books. But learning from books is not the only way to be learning maths. I'm not even sure it's the best way to be learning maths. So we want it to be just one of the ways they learn maths. And we want this engagement through what we're going to call Open Maths Lab to be some more of those ways. So these are the kind of things we want to be encouraging through the Open STEM Lab. You may do this, because you've got students in classrooms in front of you, so you may already do it. One of our challenges is we don't have students with us, they're out there. But we want it to be active mathematics, we want it to be authentic, we want to be very student-centred, and inclusive for us is important. Anyone, anytime, and any place. So the Open STEM Labs exist already. A great thing they have is they do already have at-cost partnership agreements with other institutions. So where they have an experiment, there are other institutions. In the pandemic, there were quite a few schools who used the facility of joining the Open STEM Labs and having their students work on that as well. So it can be wider than the Open University. One of the things we're going to do is have actual physical experiments cited at the OU. This is the box that was unpacked last week. This is an air track slide, and in our level 2 modelling course, new course being written for 2028 with 450 students on it, we will have a collaborative group project where students book time to work online together, and it's one of these lovely things with 2 sliders, 3 springs, and you set them off at different displacements and they boing about in beautiful ways. but which actually does show that the mathematics actually does model the behaviour. It's one of those experiments that works, not one that shows you that mathematics doesn't work. So that's the one that we're really excited on, and this is our test kit that is being planned at the moment. So it really happens, it really goes wrong if you don't set it up properly, but students will be able to control it themselves, record the outputs, and use mathematics to model the world. We also want to bring that to our level 1 students, and here you can see the size of our modules. That would reach 2,000 students when we do something on functions in level 1. We want to have, it's not just all about using maths and applying maths, we want to have some interactive screen experiments. So that's currently how we teach group symmetries. We've got very, very complicated diagrams where you might imagine how you, how you fold, how you reflect, how you rotate. And we're lucky enough to have some people in the team who are good at app design. So we want to have interactive screen experiments that again have the layered complexity, building up the use of symbols. We go through permutations, then we get onto Cayley tables and all the rest of it you're very familiar with. But we will replace sections of the textbooks with kind of sequences of gradually building up more complex activities that get us to group symmetries. Because again, with the Open University, we have a large proportion of our student body who need some form of reasonable adjustment, so we are accessible by design. And that part of bringing in the accessibility is essential for us at all points. So it won't actually look like that. That's just a game that Robert wrote, and it's quite fun to play, if anybody wants to play Digit Party. I've been interested, other people talked about real data-rich activities. We're a Department of Maths and Stats, and we're lucky as well in the Open University. We have 2 citizen science projects that we're really going to use. This is Treezilla, so this is people in Edinburgh mapping where their trees are. So we can ask our students to actually input into the system, and then we can pull the data out of the system. And similarly, we've got the Western Living Labs on campus who are collecting weather data. They do fieldcasts about that, so stratified random sampling. So we've got a lot of access to data, but it's not organised in the right way that makes it useful to teach statistics through. So this money is helping us not just to kind of map where there are opportunities, but to reorganise the data that is live and being built and structure it in ways so that it will help teach the statistics concepts that are needed at level 2 and at level 3. It's not evident that that would just happen fortuitously. So that's the kind of work we're doing there. But it does mean that our data sets will be important, that students will understand how messy they are, and that they will be changing every year as the database grows. I've put this in. I'm not quite sure what we're going to do with OpenXR, but we've got XR Studios. So we might do something around 3D symmetries, walk through 3D symmetries. We have got somebody who just says being part of a scatter plot, being part of a 3D is the most amazing thing, putting your VR headset on. I'm not sure, our students can't have VR headsets. We're going to work out what to do with that, but we really have got a lovely opportunity. If anybody had any great ideas for how to use XR Studios to teach maths, that's something that we're excited about, and we will do something with it. And then the other part of our charter as a university is to inform. And we're in Milton Keynes, but actually our events tend to be 4 Nations events, because typically it's students who can't reach universities necessarily who come to us. So you can see we do a lot of work in Scotland, in Northern Ireland, where there was a dip in maths, as we saw earlier. The southwest, sometimes obviously there is Exeter, but Wales as well. So we have events around the 4 Nations. We have our very big Open Learn platform, which gets lots and lots of visits. So we have box on their badged open courses teaching maths is one we've already written. So this LMS bid is going to help us run 11 Four Nations events over the 3 years. We're going to create new resources on OpenLearn. What's it like studying maths? Or what kind of person is going to do a maths degree? And these are not, they will link through to the Open University, but we're seeing our mission as advertising for maths generally. Yeah, we want to say anybody can do maths, there are different ways of doing maths. Yeah, you might be an Open University student, but if you want to be a campus university student, be a campus university student. We're not really in competition for the same student group, we think. And we also have an industrial advisory board. And so how we're using those is, in the middle is our changing pedagogy. That's all the internal work we're doing. We're trying to make the ways of studying mathematics be more diverse, moving it away from books, having more modelling, having more interactive screen experiments, having more interactive math learning, and the data-rich activity. And then outside, we're looking out to the world. So we're going to have the OpenLearn resources, recruiting for maths degrees, but drawing on some of the ways of working we've got in the changing pedagogy. We've got public events, which are going to go out there, and again, using some of our other resources to recruit for maths degrees. We're going to have an employability video. So the Industrial Advisory Board, they're helping us to put together short videos for every single module that we're doing. This is the maths you're learning in this module. This is how we can use it. This is what we find useful in it. And we have a massive cohort of associate lecturers training tutors. So we can't work on this without bringing the people who are student-facing with us. So we're training our 300 mathematics tutors. A short training, not nearly enough, but just something to embed all of that in. And that's our programme for the programme. We're really excited. We've already started, we've already started unwrapping some boxes. I was asked to talk about challenges. A new challenge is the bandwidth of our staff, and I put that on the same line as Gen AI, because even in November when we were writing this bid, we didn't know how much time was going to be taken up with dealing with Gen AI problems. So I don't say problems or opportunities, but bandwidth for our staff is a challenge at the moment. An old challenge for the Open University is that we're so big, we have to really think at scale, and that stops us being flexible. So I'd encourage people who can be flexible, do it. I love the idea of this pilot, proof of concept project. But yeah, how do we do it big, and how do we do it all over the 4 nations of the UK is important to us. And I think we're still convincing all our colleagues of the message that I've really heard today, that mathematical communication skills are as necessary as computational skills, and that's something we're really working on within the institution and out there. So I hope I haven't overrun, sorry.
No, you've done, no, you're fine. Thank you very much, Cathy. Cathy? Yeah, already Cathy.
Yeah, just wondering, do you have a sense of where your students are coming from, and maybe in mathematics in particular, and what draws them to the Open University rather?
I think that now Rachel might know better where our students come from. Geographically, they're very spread.
Yeah, they're spread all over.
They're just spread all over. We've got slightly more unemployed students. Strangely, there are a lot in work, but we also have quite a lot who are unemployed who are doing maths degrees, and I don't know if that's a route out of maths degrees. We have a higher proportion of students who have some kind of mental health disability, have caring responsibilities. So I think that's why it's a slightly different cohort of students who've chosen not to go to campus universities. But we do have, we have quite a lot in Scotland. And we have Ireland as well. Quite a few students coming from Ireland, not Northern Ireland.
Slightly different question. Did I understand correctly that you had one course that was completely free for, or a unit that you offered actually free of charge?
So we have our open learn resources are completely free of charge.
Yeah, but okay, that's the source. But can you take a module, take it and be accredited for free, or is it just open source material?
So what I want to say about the open STEM material that we are going to create, that can be licensed at cost to other universities or schools. So that is and that exists already, everything that's there for science. But we don't have a module that's completely free.
But I think Orica means the open learn modules, don't you, themselves, which are completely free, but they're not credit bearing, if that answers the question.
It answers the question. I was just thinking, wouldn't it be a wonderful idea to have a module that's completely free to hook people to, to entice them to try it out? But that's
is there any data published from the OU about the backgrounds of students? Generally, I wonder. Ulrika's asked the question: what's the diversity in the data? Do you publish any?
All the data is quite available on the diversity. I think the most interesting thing is around the economic diversity, and also the fact that we have this 26% of people with no A levels who are doing a maths degree. I mean that is what makes us really different.
Mine wasn't a question. Another question? It was Ulrika's question, disguised. Yeah.
Yeah. So you take in 26% of people who have no A-level maths. So it's interesting. How do you get these people up? Is this successful? Is your experience a lot of dropouts, or people really?
Yeah. So how do we do it? We have a massive pyramid. Yes. So they start. And we have a foundation, we have an access year that they can do, but actually they can join with very open, our first modules have got topics that might be quite accessible to people with just life skills, in which they're learning to formalise and they're learning to prove. So, if you started one of our level 1 modules, there's a very rapid escalation. Now, the other thing about it is that we have dropout. So dropout is built into our system, really. We try and retain people. Remember that they can learn over, how many years is it now to get a degree? 14 years is the maximum. They can do very long and slow. They can do very long and slow and just keep working on that. But one of our goals with this, we would like to up our recruitment by 10%. We would like to change our pass rates on our level 2 modules. If we up our pass rate on our 2 big level 2 modules by, I think it was 5% each, that would take 50 more mathematicians out at the end, we reckon. So because we work so big, that if we can support students through who are coming in maybe we're looking at trying to say somebody with a D at maths A level. They still chose maths. How could we get somebody who got a D at maths A level to go through our courses and come out the other end with quantitative skills and a maths degree and let them blossom? But even if they didn't blossom, even if they come out with a quite bad maths degree, they're still really useful members of society. That's what I think.
Thanks very much, Cathy. Long and slow is fine. Last but not least, Chris Brignell from the University of Nottingham.
Great. Good afternoon, everyone. I'm what stands between you and a coffee break, so I'll try to keep this to time. I'm going to talk about maths in the age of AI in just a second. But while we're thinking about these kind of maths degrees for the future, I just wanted to highlight some of the reports that we've put out as the Observatory for Mathematical Education recently, which I think speaks to the subject that's under debate here. So last week we published a review of mathematical education, which is mostly focusing on up to A level, but does have a little bit of higher education in there. But one of the findings we had in there was that when we surveyed A-level maths teachers, over 40% of them thought that you needed a grade A in A-level maths to be able to go on and do a maths degree. And over 20% of them thought you needed to have further maths to be able to go on and do a maths degree. So there's clearly some of the trends that Paul Wakeling talked about earlier. There's clearly some messaging that needs to get through to maths teachers about who can do maths at university. Earlier in the year, we put out another couple of reports. One was on the landscape of undergraduate degrees in England and Wales, so apologies to Scotland, Northern Ireland and the Open University. But that was looking at the similarities and differences between our different programmes as they currently stand. There's lots of variety between our maths degrees. And I think there's a challenge for us as to how do we communicate that to young people. How does the maths degree at Nottingham differ from a maths degree at another institution? And the other third one we put out was the transition to university mathematics, which surveyed over 700 students across 65 different universities across the UK, both before they started university and then 6 months later. And we see a massive drop-off in confidence during those first 6 months of university. The rug is pulled out from under their feet, the mathematics that they love changes, their support structures change, their education, pedagogy changes. So there's lots of detail in there, and particularly the drop-off for female students. The drop-off in confidence of female students is much higher than for male students. So again, I think there's probably some work for us to do as a community, and that's just some food for thought. And I've just realised I've got Paul's picture up there. I didn't get your written permission to put it up there. Am I right to use your picture?
I'm here, so
excellent. And also, from January, I'm taking over from Sophie Carr as the RSS Vice President with responsibility for education. So if you want to talk about the role of statistics and data education in university and schools over the next couple of days, do come and find me, or also talk to Rachel or Joanna, who are also here wearing RSS hats as well. Right, maths in the age of AI. I thought our revolutionary big idea is to include calculators in our maths degree. The relationship between maths and technology has constantly evolved over time. So when calculators were brought in, some people thought this is brilliant because now the students don't need to worry about the calculations, they can focus on the concepts. Whereas other people thought it's a travesty if people qualify from a maths qualification not being able to do mental arithmetic. And of course, computers came in, that's revolutionised mathematics. I learned to program by sitting in a lecture theatre copying down computer code that was written on an overhead projector in Fortran. I'm showing my age there. I spent my PhD doing MCMC algorithms. The advent of computers has changed fundamentally what we do with mathematics, but it's also fundamentally changed how we teach mathematics. And obviously the internet comes in, that changes things again. No longer do you need to walk to the library to find a book to explain something to you. Some of you may remember the days when libraries had books in them rather than cafes. But again, the internet has changed things. Some people say it's a good thing because we no longer need to remember all the assumptions of a particular theorem. You can just look them up on the internet in a few touches of the mouse clicks or whatever. But again, it's changed the way that we teach because we have virtual learning environments and so on for our resources. So our bid for this Maths Degree to the Future was centred around, well, what does mathematics look like in the age of AI, and how do we teach mathematics in the age of AI? One of the reports I mentioned earlier, the transitions report, we asked the students before they started university on the left-hand side and after they've done one semester of university on the right-hand side, do you use AI? Is AI helpful for learning mathematics? So at A-level, or Scottish Highers, or whatever they studied before, around 10%, 15% of students found AI was useful for learning mathematics. After one semester of university, over half of them are using AI. So even if we want to bury our heads in the sand and pretend that AI doesn't exist, the students are already using it. But we're not teaching, or certainly in Nottingham today, we're not teaching students how to use AI for doing mathematics. And the different colour bars here correspond to their expected first year average mark. I should have asked you to guess what the So AI is being used by almost 3/4 of students who are on track for a third-class degree or worse. Whereas the good students, well, still over half of them are still using it. So are they using it to cheat or are they using it to learn mathematics? We can have a little debate about that, but there's a correlation here. I don't know if it's correlation between expected mark and the use of AI. If you contrast it with the top graphs where they're using maths to plot data or to visualize functions and so on, you can see the trend is completely the other way around. So clearly AI is here to stay. So how do we embed this into our programme. So I guess the concept for the Nottingham programme is to put across to students that mathematics is what is underpinning AI. It's not magic, it's just a mathematical algorithm running in the background. It's changing how we do mathematics. So one of my students, I said to one of my students last week, I sent them a coursework assignment and said, you can use AI to do the programming for this coursework. And she said, really? I said, yes, you can do that. She said, oh, well, I do that in my job. I use AI to do programming in my job, but I didn't realize I was able to do it in the university. I was like, well, for this one, yes, you can. I'll allow you to use it. But as a mathematician in the workplace, she's using AI to do some programming tasks to supplement her mathematical skills. Well, so it's changing the way we do mathematics, and obviously we need to then update how we teach and learn. So our big idea is not that revolutionary, but we're thinking about how do we modify our current undergraduate mathematics programs such that it's clear in the curriculum and the teaching and the assessment that we're living now in an age where AI is here to stay. Obviously, we also want to achieve other goals like widening the appeal to underrepresented groups. And we also want to make sure that there's a lot of system inertia. Dan talked about the challenge earlier of changing a program at King's and it taking 2 years to go through all the processes. Mathematics and technology is changing rapidly, and we need to have a new way of thinking about our degrees, which enables us to keep pace with current developments and overcome kind of the system inertia, which means that progress happens slower than technology. So what are we trying to do? We've got kind of 3 themes with 6 kind of work packages underneath it, but one of them is to embed AI in our curriculum, our teaching and our assessment. That's where the bulk of the work is going. We're also trying to increase participation in mathematics, and we're also thinking about this rapid evolution of maths degrees. So if I just kind of pick up each of those 6 little sub-themes one by one. So the first one is to redesign our curriculum to put AI, mathematics that underpins AI into some of our undergraduate modules. So for example, we're introducing a new second year module in the next academic year, September 26, about natural language processing. Essentially explain to students what is mathematics that underpins generative AI. But there will be other modules that come in subsequent years in year 3 and year 4. And the core mathematics which we're teaching in year 1 is going to stay, because fundamental mathematics needs to stay part of the program. But where there are links to LLMs and AI, they will be highlighted. So the linear algebra, the calculus, the probability statistics, where it links across to AI, will make that clear to the students that they know that they're learning mathematics, which is underpinning AI algorithms. In year 2, the second project that we're doing is to think about how do we put AI into our teaching and assessment. So we've used some of the money to employ a teaching fellow who's researching different ways that you can use AI. So far they've come up with 125 different ways that we could use AI to do teaching and learning and assessment in mathematics. I'm not suggesting we're going to try all 125 of them. So at the moment, I guess our process is trying to go down that list and trying to work out which of these things can we pilot in one or more of our modules. And of course, also in both of the first 2 things I've talked about, we're also working with student interns to kind of co-develop some of these things. We're also initiating expanding our program of outreach and participation. So one of the things we're hoping to do in summer 26 or summer 27 is to run a summer school dedicated to supporting female year 12 students from the East Midlands who might want to, who we can hopefully persuade to come and do a master's degree at Nottingham or elsewhere. But what we're trying to do is also develop a suite of interactive resources which highlight the importance of AI and mathematics and the link between the two. So this is a kind of a prototype for one we've already developed, which is it's an app or a kind of interactive touchscreen tool where students can think about how do we deploy cancer treatments to prolong or rather curtail the growth of a tumour. And so they can do it manually and they can come up with their own treatment strategy and seeing if it works. But then also we've got an AI algorithm here which is slowly learning what is the optimal treatment pattern to curtail this cancer growth. So we're going to have a suite of such interactive tools. This is an interesting one, which is perhaps our most ambitious one, which is develop a year in mathematics. And the idea here is that we heard about the Open University. We want to go much smaller and think about the Nottingham University, but we want to make sure that mathematics is an option for every student in the university. So we've developed, or in the process of developing, which will run for the first time next year in 26-27, a year in mathematics. This is a year in data analytics and AI, and it's open to any student in the university who can add it on as a sandwich year. So instead of a study abroad year or a year in industry, they can do a year in data analytics and AI as a kind of standalone one-year program. So they might be doing a psychology degree or an English degree. They won't be doing music or foreign language, because we'll just cut those. But they'll be doing other degrees, and they can then choose to do a year in mathematics as a way of getting some access to advanced maths. And we'll be developing another program, which is a year in mathematics, which is more designed for A-level students with A-level maths, but have chosen to study a different subject. So again, it's about increasing and diversifying the number of students studying higher degree mathematics. And then the fifth and the sixth work packages are not yet in train, but it's about monitoring, responding, collaborating, dissemination. One thing that may be of interest to, well, two things that may be of interest to this community. One is the hosting of educators in residence. We're going to use some of the funding to invite esteemed colleagues from around the country to come and work with us at Nottingham for a little bit, or we can come and work with you and your institution for a little bit to try and foster collaboration between us in the development of some of these things that we're talking about. And also going to be hosting education conferences, and one that's coming up in Nottingham is approximately 1 year from now is the British Congress of Mathematics Education, BICME. It didn't take place 4 years ago because of COVID, but it did take place 8 years before that, and we're restarting it in Nottingham on October 26th, and you are all invited. Thank you.
One question due to my net chairing. I won't ask you because you've already asked the question. Apologies. Yes, chap at the back. You can ask him later.
Yeah, I was very interested in your year in maths. And my question is, at what point will students decide to do that? Will they apply for the original programme with a year in maths, or does it come later?
It comes later. So during their second year, typically, of their undergraduate programme, we will be marketing it internally across the university, and then at that point they can come and talk to us, and if both they and us think that it's a good fit for what they want to do, they can then transition to a psychology with a year in maths degree, or an English with a year in maths degree, or whatever there is a home subject.
Okay, and the reason I ask is that if you are changing the length of the degree programme partway through, we've had big problems with this because of, for example, students on a visa, a fixed programme length. How are you going to deal with that?
So international students, I think, is a special case of that. For home students, you can normally add on a year without it being a problem. We've already we've got other examples of programs like this already in our university. So we've got kind of environmental science with a year in computer science, or natural sciences with a year in computer science. This is creating a mathematical equivalent of that, because we don't want the computer scientists to have all the fun.
Imaginative solutions to any of the challenges you see are very welcome. I think you'd all agree that we've got a diverse range of 5 projects that have been worked on, huge amount of work. For you, it's not the beginning, but obviously for us, it's the beginning hearing about these. But this is for you. All of this work has been done so that we can all gain from that. Two things. One, I'd like to thank Jens Markloff, who is he in the room? He was the chap, as far as I'm concerned, that dreamt this programme up. So I think we have huge thanks to you, Jens. So thank you for that.